Okay, so here are the kinds of problems that we're going to be working today. We have here a parallelogram. We're going to know that it's a parallelogram. Either the problem is going to say this is a parallelogram, or it's going to have the markings for parallel lines like so, and that's how you're going to know that it's a parallelogram. And then there's going to be some measurements on it, and so today we're not looking at naming the shapes like before. We're now looking at finding the measurements based on the properties. So let's say that this side is 3x plus 2, and this side over here is x plus 14, and this side over here is x plus 5. And our job is to find x. Alright, so we want to use a step-by-step process. And so step 1, we want to know the shape that we're dealing with. So this shape is a parallelogram. It has two pairs of opposite sides that are parallel. And so once we know that it's a parallelogram, on our chart, we know we're looking at this top row for parallelogram. Alright. Then step 2 is to decide SAD. Alright, don't be sad, but we are going to be talking about the letters in SAD. SAD means to decide. Is this problem talking about sides? Is this problem talking about angles? Or is this problem talking about diagonals? SAD. Every time you do these, that's the second question you want to ask yourself. So when we look here, these measurements are on the outside of the shape. So these are measuring the lengths of the sides. Like with a ruler, it's measuring the length of the sides. So this one is a sides problem. So on our chart, if you'll note here, and this is your chart to keep so you can write on it, this black line here, everything here is about sides. Everything in between these two black lines is about angles. And then everything past this black line is about diagonals. So it kind of helps you know where to look. So this is about sides, right? So we're on sides and we're on parallelograms. So opposite sides are parallel. Well, that's a real nice thing to know, but that doesn't tell us about the measurement. That just tells us that they don't intersect and they have the same slope. But it also says opposite sides are congruent. Aha, that's what we need. Opposite sides are congruent. So let's look at this. Which ones of these are opposite sides? Can you see that AB and DC are opposite sides? Because they're across from each other. So we're going to look at those two opposite sides, and this x plus 5, we don't even need that guy. So the opposite sides are congruent. That means they're equal to each other. So step 3 is to do your equation. Right? Once you know what it is you're talking about, you do your equation. So 3x plus 2 equals x plus 14. Once you get to right here, your geometry is done. Now you're just doing algebra. Right? Helps to draw your vertical line. And we have x's on both sides. So when the x's are on different sides, you want to subtract your x's that are on the lowest side. So I'm going to subtract x from both sides. 3x take away x is 2x. Bring down my plus 2. X take away x is 0. Bring down my 14. Now I'm going to get minus 2 from both sides because I'm trying to get this x by itself. 14 subtract 2, 12. Then I'm going to divide both sides by 2. X is going to be equal to 6. Now, what if after they said to find x, what if they said find DC? Alright, well DC is right here. DC is x plus 14, but I know x is 6. So I'm just going to do 6 plus 14. Right? So I'm just plugging in the x. I'm plugging a 6 in place of the x, and that's going to equal 20. And now if I want to make sure I did it right, I can go see my other side. 3 times 6 is 18, and 18 plus 2 is 20. So 20 and 20, opposite sides are congruent. It checks out. Alright, that's example 1. Example 2 looks like this. Let me give you a second to write that down. Alright, so we want to go through our same thinking process. First, we want to see what shape this is. Opposite sides are parallel, so this is a parallelogram. Alright, don't be sad, but figure out, are we talking about sides or angles or diagonals in this problem? If it says 65 degrees, that's got to be talking about angles. Alright, so the next thing you do is you get your chart. We're on a parallelogram, and we're talking about the angles. So we've got to look at this part right here. So it says opposite angles are congruent, and it says consecutive angles are supplementary. You might want to write this on your green paper as a reminder. Supplementary adds to 180. You might want to put a 180 on top of that word supplementary just to remind you. Alright, so let's look at angle D with angle B. Angle D and angle B. Do you see that those are opposite angles? Right? Angle D, angle B, those are opposite. And our chart says opposite angles are congruent. So if angle D is 65 degrees, then angle B is also 65 degrees. Easy peasy. Alright, but now what about the measure of angle A? So now you got to look. If this is angle D right here, and this is angle A, these are not opposite. These are called consecutive. One right after the other. So angle D, angle A, that's consecutive. So my chart tells me that consecutive angles are supplementary. They add up to 180. So that means angle A added with 65 degrees equals 180 degrees. Add the two angles up and it'll equal 180. So to know angle A, we're going to subtract 65. Right? It's going to be 180 subtract 65. And then angle A is going to end up being 115 degrees. Alright, third and final example. Alright, so the first thing we have to do is name the shape. So you see that you have 4 corners marked as 90-degree angles. So what shape has 4 90-degree angles? All angles are right angles. It's a rectangle or a square. But remember, a square has all sides congruent. These sides aren't congruent, so this must be a rectangle. Alright, then you will not be sad if you determine, are you looking for sides, angles, or diagonals. Look at where your figure is marked. The sides are around the outside. It's not that. The angles are all right there. They're 90 degrees. These guys that come in like this, these are the diagonals. This is a problem about diagonals. So that's where I'm going to go to my chart. I'm going to look for rectangle, and I'm going to come down here to diagonals. It says diagonals bisect each other, and it also has a check under diagonals are congruent. Okay, so remember, bisect means to cut in half. So if this diagonal cuts it in half, that means this half and this half are the same, right? So it means 4x equals x plus 8. Oh, you know what? I wrote this down. My bad. It's supposed to be a 9. I was looking on my other paper. Change that over to a 9. Sorry about that mistake. That 8 should be a 9. Alright. So now we're going to subtract x from both sides. 4x minus x leaves us with 3x. X take away x is 0, so bring down our 9. Then divide both sides by 3. X is equal to 3. Alright, let's add one more thing to this problem. Let's go call this R, E, C, T. So x is equal to 3, but what if they wanted me to find RC? If I wanted to know how long it is from R to C, I would have to take my answer of 3 and I would have to go plug it in, right? So 4 times 3 is 12. But then I'd have to take the 3 and I'd have to plug it in over here too. 3 plus 9 is 12. And I'd have to add the two 12s together and get 24. Oh, what if I had one more part? What if they wanted me to find E.T.? Have y'all ever seen the movie E.T.? If y'all have not seen the movie E.T., you need to watch E.T. It is an adorable movie. And it makes your heart feel all warm. And there's a ride about it at Universal Studios in Orlando. The E.T. ride is very fun to go on. Anyway, if you wanted to find E.T., you'd look in the closet, because there's a scene where E.T. is hiding in the closet. And I think he's eating Reese's Pieces in there. It's an old movie, guys, but it is fun. Alright. So E.T., not the extraterrestrial, but E.T., the diagonal, is right here. So again, we go to our chart. Diagonals are congruent. Diagonals are congruent. So that means if RC is 24, ET has to be 24. And if somebody said, I don't believe you, how do you know it's 24? What's your reason? Explain it. You would say, diagonals are congruent. So that's why I know. So there.